Welcome students to the video today. So far we've looked at factoring trinomials with a lead coefficient of 1, factoring trinomials that do not have a lead coefficient of 1, and factoring binomials that are perfect squares. In this video we're going to be looking at the other type of binomial that we need to factor. And this type of binomial is called the sum and difference of perfect cubes. The sum and difference of perfect cubes. Okay? And so your heading today, I'd like you to write this down. Your heading is factoring sums and differences of perfect squares. Factoring sums and differences of perfect squares. Be sure and write the date right here so that you have record in your notes of what the date is today that we cover this information. Okay? Factoring sums and differences of perfect squares. Now, here are the steps for factoring for factoring this type of binomial. Step 1, always pull out what's common. And that's always what we do first when we're factoring. Pull out what is common. Step 2, make sure that you have a binomial in which both terms are perfect cubes. And we'll talk more about that expression, perfect cubes, later. Step 3, factor. Okay? Step 3, factor. So with this in mind, let's take a look at 3 problems, and only 3 problems today. Okay? And let's see if you can't learn how to factor binomials in which they are sums and differences of perfect cubes. Now be sure and take some really good notes and make sure you understand what you're doing, okay? Alright, let's go ahead and factor this binomial, okay? Step 1, we're going to pull out what is common. Now, notice I have a 1 here and a 27 here. There is no number that goes into 1 and 27 evenly except for 1, and we're not going to pull a 1 out. Notice I have x's in this term, but I have no x's in this term, so I cannot pull out any x's. So step 1 is done. Pull out what's common. Now step 2 says make sure that you have a binomial, and we do, in which both terms are perfect cubes. Well, perfect cubes means that you can take the cubed root of a number or a term. For example, the cubed root of 8 is 2. How do I know that? Because 2 times 2 times 2 equals 8. And so 8 is what we call a perfect cube because I can actually take the cubed root of 8. Okay? So we're going to see or make sure that both of my terms are perfect cubes. Now, do I know the cubed root of x cubed? Well, sure I do. X, because x times x times x is x cubed. So I definitely know the cubed root of x cubed. Do I know the cubed root of 27? Well, sure I do. 3, because 3 times 3 times 3 is 27. So, yes, I have a binomial, and yes, both of my terms are perfect cubes. Now, students, would you please listen to me carefully? Step 3 says to factor. I'm not going to give you steps for these. I'm going to teach you a procedure, and I need you to draw arrows and write a bunch of side notes, okay? So here's what we do. First of all, you write a relatively small parentheses, and then you write a larger parentheses. So take some really good notes on this, okay? Next, in your head, you take the cubed root of this term, and the cubed root of x cubed is x, so you put that x right here. Okay, take some really good notes on that and write down some side notes so you know what to do later on your own. In your head, you take the cubed root of this term. Well, the cubed root of 27 is 3. 3 times 3 times 3 is 27. So you put a 3 here, and then whatever this sign is right here, you bring it down and you put it right here. If it would have been a positive sign, then I would put a positive sign here. Okay? In this case, it's negative, so I'm going to put a negative sign here. So take some really good notes on that. Now, over here, we're going to have three terms. A term here, a term here, and a term here. Now watch carefully what I do. In your head, you always take this first term and you multiply it times itself. So x times x would be x squared. And you put it right here. Take some really good notes on that. Now, this term right here, this 3, you multiply it by itself, or you multiply it times itself. So 3 times 3 would be 9, and you put that over here. Now, for your middle term, you take this term here, which is x, and this term here, which is 3, and in your head you multiply them together. X times 3 is 3x, and you put that right here. Now you're probably saying, Mr. Earhart, what about your signs? Do I put a positive or a negative here? Do I put a positive or a negative here? And that's a good question, and here's how you know. This first term here in the big parentheses will always be positive, always. And this last term here will always be positive, always. So take some good notes on that. Write down what you need to. This sign here will always be the opposite of this sign here. So if you have a negative sign here, which we do, then you're going to put a positive sign here. Okay? If you would have had a positive sign right here, then you would put a negative sign here. It's that easy. Okay? And so because I have a negative sign here, I'm going to put a positive sign here. And by the way, if I were to take this binomial here and multiply it by this trinomial here, I would get this right. I'm going to do it for you really, really, really fast. I'm going to take this x and I'm going to multiply it through times all three terms. X times x squared is x cubed. X times 3x is 3x squared. X times 9 is 9x. Now I'm going to take this negative 3, I'm going to multiply it through the other parentheses times each term. Negative 3 times x squared is negative 3x squared. Negative 3 times 3 is a negative 9x. And negative 3 times 9 is a negative 27. Now, notice your 3x squared cancels with your negative 3x squared. Notice your positive 9x cancels with your negative 9x. And you're left with x cubed minus 27. Okay, so you need to memorize this procedure when it comes to factoring the difference or the sum of perfect cubes. Let's try two more. Okay, step 1, pull out what's common. Well, there's a 1 here and a 64 here, and so there's really nothing common we can pull out when it comes to numbers. There's 6 y's here, there's no y's over here, so there's no y's that I can pull out either, so there's nothing I can pull out that is common. Step 2 says make sure that you have a binomial in which you have perfect cubes. Well, let's start with the y to the 6th. Do I know the cubed root of y to the 6th? Well, let's see. Let me ask you a question. What's y squared times y squared times y squared? Would that not be y to the 6th? Because when you're multiplying like bases, you add the exponents. Y squared times y squared is y to the 4th, and y to the 4th times y squared is y to the 6th. So yes, we know the cubed root of y to the 6th, and the cubed root of y to the 6th is y squared. So yes, y to the 6th is a perfect cube. Now, is 64 a perfect cubed? Well, I say it is, and I say it's 4. If you take 4 times 4, you get 16, and then times 4 again is 64. Now, you might say, Mr. Earhart, how do you know these numbers so quickly? Well, I've done this for years, and you'll kind of catch on to this as we do more and more of these, okay? But yes, 64 is a perfect cube. We do know the cubed root of 64, and it's 4. So step 2 is done. We do have a binomial in which both terms are perfect cubes. Step 3 says factor. So here we go. We've already learned how to do this. You put a little parentheses and then put a pretty big parentheses, okay? Now this procedure is used when you're dealing with perfect cubes. Don't forget the other day we learned how to factor perfect squares. And in that situation, when you know the square root and the square root, remember you put two little parentheses, and the square root of x squared is x and x. The square root of 16 is 4 and 4. Make one positive, make one negative. Those are a little easier. But today we're not dealing with perfect squares. Today we're dealing with perfect cubes. Okay? So remember, in your head, you take the cubed root of this term, and the cubed root of y to the 6th is y squared. Next, in your head, you take the cubed root of this term right here, and the cubed root of 64 would be 4. And then whatever this sign is right here, you bring it down and you put that sign right here. Okay? Now remember, over here we're going to have three terms. Okay? A first term, a middle term, and a last term. So you take this first term here, y squared, and in your head you multiply it times itself. So y squared times y squared would be y to the 4th. You put that right here. Now take this term and multiply this term here times itself. Well, 4 times 4 is 16, so you put the 16 right here. Now, next, in your head, you take this term here times this term here. Y squared times 4 is 4y squared. Now remember what I taught you about your signs here and your signs here. What I taught you is this first term here is always positive, and this last term here is always positive. However, this sign right here will always be the opposite of this sign right here. So if this is positive right here, which it is, then this sign right here will be negative. And you're finished. Moving on to the last problem, and we're finally done. Now, let's be really careful here, okay? First of all, pull out what's common. Well, you never want your first term to be negative. And I notice I have a 2 and a 16. So I know for sure the largest number that goes into 2 and 16 is 2. And I definitely want to pull out a negative 2 because I never want my first term to be negative. Okay? Now next, I've got 10 A's here and 1 A here. So there's no way that I can take 10 A's from both of these terms, but I can definitely take 1 A from both of these terms. Now look at your x's. You have 1x here and you have 1x here. So I can pull 1x from both terms. There we go. Now go ahead and put a little parentheses. Let's see what we're left over with. Okay. Well, here, if I've done this correctly, I think I would have a to the 9th, because negative 2 ax times a to the 9th would be negative 2 a to the 10th x. And over here, I'm pretty sure I'm going to have a positive 8, because negative 2 ax times a positive 8 would be a negative 16 ax. So there, I've pulled out what's common. Now notice what you're left over with here would be two terms, and look what step 2 says. Step 1 is done. We've pulled out what's common. Step 2 says make sure you have a binomial, which I definitely have a binomial, in which both terms are perfect cubes. Well, let's see. Do I know the cubed root of a to the 9th? Well, I say yes. I say it's a to the 3rd, because a to the 3rd times a to the 3rd times a to the 3rd equals a to the 9th. A cubed times a cubed is a to the 6th times a cubed is a to the 9th. Remember, when you're multiplying like bases, you add the exponents, okay? Now, do I know the cubed root of 8? Definitely. The cubed root of 8 would be 2, because 2 times 2 times 2 equals 8. So the cubed root of 8 is 2. All right? So yes, both of these numbers are perfect cubes, so I can factor this. So we're going to bring down our negative 2ax. That's what we pulled out. And then we're going to put a little parentheses and then a big parentheses. Now, why am I putting a little parentheses and then a big parentheses? Why did I not put two big parentheses? Well, the reason is, or two little parentheses, because I'm dealing with perfect cubes. And whenever you're dealing with perfect cubes, you put a little parentheses for a binomial and then a bigger parentheses for a trinomial. Now, in your head, you take the cubed root of a to the ninth. Well, the cubed root of a to the ninth is a to the third. And in your head, take the cubed root of 8. That's going to be 2. And now bring this positive sign down right here, and we're going to put a positive sign right here. And then remember, over here I'm going to put 3 terms, okay? We'll worry about the signs of those terms later. Now, you take this term right here, a cubed, and you multiply it times itself in your head. Well, a cubed times a cubed is a to the 6th. Now you take this term here and you multiply it times itself in your head. Well, 2 times 2 is 4. And then you take this term here and this term here, and in your head you multiply them together. So a cubed times 2 would be 2a cubed. Now, remember, this first term here is always positive. You don't have to put a plus sign. You can if you want to. You don't have to. This first term here is always positive. This last term here is always positive. And then whatever this sign is right here, you always put the opposite sign right here. And you're done. That's it. Congratulations, you've done it. So today we have looked at factoring the sums and differences of perfect cubes. Okay? I hope this has made sense. I hope this has been a help to you. Do not hesitate to call or email if you have any questions.